final two quadrilaterals that we're going to talk about are trapezoids and kites. So first things first, trapezoid, it's a quadrilateral with exactly one pair of parallel sides. So parallelograms and rectangles and squares and all those things, those have two pairs of parallel sides, where a trapezoid has one pair of parallel. So I got one on the left here and I got one on the right. The one on the left's a little bit different. This is kind of a special trapezoid because these two legs right here are congruent. So we would call that, well, when two sides are congruent, just like a triangle, it's called an isosceles. So this would be an isosceles trapezoid. Okay, and we got some special properties, especially for the isosceles trapezoid. So let's take a look here. Two of them. So if a trapezoid is isosceles, that's important. If it's isosceles, then each pair of base angles is congruent. So for example, this trapezoid is isosceles. That means the base angles on the bottom are congruent to each other, and the base angles on the top are congruent to each other. All right, so for example, let's say this is 100 degrees right here. This guy would also be 100 degrees across from it on the bottom. If this was, well, that would make this one, what, 80 and 80, because I have to add up to 360. So there you go. And then vice versa, right? If a trapezoid has one pair of congruent base angles, like it does right here, then we know it's isosceles. Last thing about a trapezoid is isosceles if and only if the diagonals are congruent. So this is a lot like a rectangle. If it's an isosceles, the diagonals are congruent, right? So that means these two blue pieces would be the same distance. They would be congruent. Okay, it wouldn't work for a non-isosceles, right? If I had something like this, here's the trapezoid, kind of an ugly one, but if I drew in the diagonals here, do those even look congruent? No, not even close, okay? So it's only for isosceles trapezoids. So let's use that to find some information. We got a basket, and it says that it's isosceles trapezoid in that basket. So I know that these sides are congruent. If JML, so that's this whole thing right here, JML, that's 130 degrees. So 130 degrees. And KN is 6.7 feet. I'm going to draw that in here. KN, 6.7 feet. And MN is 3.6 feet. So that's down here. MN is 3.6 feet. Find each measure. So it wants us to find JL. So that's this entire diagonal. Well, we know in isosceles trapezoids, we just learned that the diagonals are congruent. So that's the same distance as MK. And MK is just the two little segments added together. So 3.6 plus 6.7, which gives us 10.3. So JL is 10.3. Don't forget your label, feet. Now we also want to find angle JKL. Well, where is JKL at? That's like up here. I'm going to erase some of this information here. I'm not using it anymore. So JKL is up top here. I want to find that angle right there. Well, let's just start finding things that I do know. Well, if this is 130, the angle JML is 130. The other base angle that goes with it is also 130. So I know that this is 130. Okay, so if those two are 130, that totals 260. And I know that quadrilaterals add up to 360. So if I subtract those two, I have 100 degrees left to work with. Well, and I got two angles that are the same. So I could just cut that 100 in half. So I know that JKL has to be 50 degrees. 50 degrees. There you go. So just using the information that you know and the properties that we learned about isosceles trapezoids. Okay, we can also put them on a graph and determine if the quadrilateral is a trapezoid, and also look to see if it's isosceles. Okay, and we're going to use our theorems that we just learned. So let me go ahead and graph this. So I got A is at 5, 1. So I got 2, 4, 5, up 1. There's A. I got B at -3, -1. I got C at -2, 3. And I got D at 2, 4. So I'm going to draw this in. It won't be very pretty, but do the best I can. Okay, so first thing, if I want to prove that it is a trapezoid, what's the main theorem? I have one pair of parallel sides. So one pair of parallel sides. So that means I need to prove that CD, the slope of CD, is parallel to the slope of BA, right? Because I know that parallel slopes are the same. So I want to see that their slopes are equal, right? I want to prove that these two lines are parallel. Well, I could use the points. I could use the slope formula, but why don't I just count it? Much easier. So if I go start from C and go to D, I go up 1, right 1, 2, 3, 4. So rise over run, up 1, right 4, 1/4. Do the same thing for B to A. So I go up 2, right 1, 2, 3, 4, 5, 6, 7, 8. So I went up 2, right 8. Let's simplify 1/4. So there we go. I know it's a trapezoid. Well, now let's see if it's isosceles. Well, how do we do that? I want to see if CB is congruent to DA. So I want to find the distance of CB and then see if the distance is equal to DA. So CB, so remember our quick shortcut for our distance formula. Take the square root. We find the distance between the x's. So between, whoa, did not want to do that. So the distance between -2 and -3 is 1. So 1 squared. Plus the distance between the y's. Well, from -1 to 3, it's 4. So 4 squared. So that simplifies to, we got 16 and 1. So the square root of 17. Then I do the same thing for DA. So the distance between your x's. So the distance between 2 and 5 is 3. So I got the square root of 3 squared. Plus distance between your y's, 4 and 1. Which is also 3, so 3 squared. And that gives me the square root of, well, 9 plus 9 is 18. So they're not quite the same, are they? Boy, they look pretty close, don't they? So what we would say, we'd give it a name. So either say trapezoid or isosceles trapezoid. So it is just a trapezoid. And that's just fine. If you want to state that it's not isosceles, that's fine. But I'm going to cross those guys out. So that one's not isosceles. They're not quite congruent on the sides. Our another theorem with our trapezoid is that the midsegment, the line that's like right in the middle of the trapezoid, okay, it's like halfway between the parallel lines. The measure of that is 1/2 the sum of the lengths of the bases. Okay, before I kind of write it out mathematically, let's just think about that. So let's just say AB is 10 units, DC is, let's say, 30 units. That means EF would be, well, I'd take the sum of these two, so 10 plus 30, which is 40, and it's half of that. So 40 divided by 2 is 20. So I know that EF is a distance of 20. And so really all I would have to do is to find EF, the midsegment, I'd take half the two segments added together, the two parallel lines, so AB plus DC. So I can kind of use that formula there, or if I can think through it mentally, that might actually be easier in this case. Let's take a look at an example how we can do it both ways. So in the figure, EF is the midsegment of the trapezoid ABCD. What is the value of X? Okay, well, let's first do this mathematically. Okay, I know that EF, right, that's half of the two bases added together, or the two parallel lines added together, so AB plus DC. So it's really 30 equals 1/2 times 20 plus X. Okay, so now this gets into algebra, right? So it's much easier to do this mentally, but I could times by 2 to get rid of that half. So that's gone. So I got 60 equals 20 plus X, and I should see that X equals 40 there. And if I do this mentally, well, I think about it, this 30 is half of these two added together. So I could just go ahead and double it. So 30 times 2 gives me 60. So now I just think, well, 20 plus what gives me 60? 40. So I know that it has to be 40. So a couple different ways to do that. I would prefer mentally. I think it's just a little bit easier than going through the math. And it should make sense, right? If I solve for X, this should be the biggest side by looking at my trapezoid. Things like that. Our other shape we're working with is a kite. And that's a quadrilateral that has exactly 2 pairs of consecutive congruent sides. So that means, like, here's a side. So the side right next to it's also congruent. And then I have another set of those. So this side and the side right next to it's also congruent to it. That would be a kite. So this is not a parallelogram because opposite sides are not parallel. Well, let's take a look at a couple theorems with that. So if a quadrilateral is a kite, then its diagonals are perpendicular. So in this case, these black lines are the diagonals that are drawn in. And if you take a look, they make a perpendicular right in the middle. So if diagonals are drawn in and there's a perpendicular, and you know that these sides are congruent and these sides are congruent, it is a kite. Our other theorem is, if it's a kite, then exactly 1 pair of opposite angles is congruent. Okay, this is kind of tricky. If you take a look, these are the two angles that are congruent, correct? Okay. The one thing that gets mixed up is some people try to set the top and the bottoms congruent. These two are not congruent. These are not congruent, okay? It's only the ones like in between the two different sides. So you see how like this side is different from this side, and this side is different from this side. So it's the angles in between there are the ones that are congruent. All right, so let's take a look at that using an example. So if WXYZ is a kite, find measure of XYZ. So we're going to try to find this guy right here. So a lot of people will think, well, it's got to be 73, right? Opposite angles. Well, think about this. Which two sides are congruent? These two are congruent to each other, and these two. So the angles that I know are the same are this 121 and the Z. So X and Z are the same. So I know that Z is also 121. So just careful. Take your time. Think about that property. So to find what angle Y is, or XYZ, we have to add up that 121, 121, 73. And in this case, we get 315. Subtract that from 360, which gives us 45. And that's it, right? 45 degrees, okay? Because quadrilaterals add up to 360, so you're just using information that we know about quadrilaterals, and we can solve from there. And the last one, if MNPQ is a kite, find NP. So I'm trying to find what this side is. Well, let's think about it. What else do I know? That side has to be congruent to what other side? MN, right? Because the consecutive sides are congruent. It's not to QP, okay? What else do I know? I know that kites have a right angle for the diagonals. Well, if I look here, what kind of triangle do I have? A right triangle. And I know two sides, 6 and 8. So that means I can use the Pythagorean theorem. So to find MN, I can use 6 squared plus 8 squared equals C squared, right? A squared plus B squared equals C squared. So we got 36 plus 64. This is kind of our convenient one because those add up to 100. And we take the square root. So I know C is 10. So that MN is 10, which means NP also has to be 10. So there we go. I know that it is 10 units. So there we go. So working with our trapezoids, kites, got a couple theorems for each, and then using knowledge that we've learned before, you know, like Pythagorean theorem, quadrilaterals add up to 360, all that other jazz. All right, good luck to you.